Okay, so today we're going to talk about, we're going to do two lessons. We're going to do 1.6 and 1.7. All right, 1.6 is relations and functions. We're going to identify the domain and range of relations and functions. And we're going to determine whether a relation is a function or not. All right, couple of basic things here. So first of all, a relation is a pairing of input values with output values. It can be shown as a set of ordered pairs, x and y, where x is an input, y is an output. Or it could be shown in a chart like this, where we might have the domain on the left side and the range on the right, and arrows connecting them. So this would give us the set of ordered pairs 2a, 2 in B, and 2 in C. Right? So since the arrow is going to all three of them. Right? So our input values and our domain are the same thing then. Right? So our set of inputs will be called the domain, the set of outputs are the range. Okay? So identifying domain and range. So here's a set of points, a relation. Right? We want to identify the domain and range. When you do this, right, you have to use braces to represent them when they are individual values. If it's a whole group of values, like all real numbers or the natural numbers or something like that, then you don't have to. But if it's just a group of numbers, then you need to represent them with braces. So when I list the domain here, all right, and the domain is what values? The x's, all right? So we'll put braces, and when you list them, domains and ranges, you always list them from smallest to largest, all right? So in this case, our domain is going to be 100, 120, 140, 160, and 180. So I'll list all of them. And close that with a brace. All right, now the braces you make, I know that everybody or lots of people struggle with making them. Sometimes mine don't look all that special either, okay? So just do the best you can with them, all right? Basically, it's a little squiggle sometimes, right? So the range is our y values, and in any case on these, when we do the domain and range, right, we go smallest to largest, and you only list them one time. So when we look at our y values, we have 5, 5, 6, 6, and 12. Well, we only list 1, 5, and 1, 6 to get that range. All right? Don't do 2 5s and 2 6s. That doesn't mean anything. Once you've listed a 5, you've covered that number, so you don't need to do it again. All right? Because we're not putting these so that they're paired up. We're just saying what those numbers are. And I know sometimes that's what you guys want to try to do, is to pair them up, but you don't need to do that. Okay? All right, so for this graph here, go ahead and list the domain and range. Right. A function is when there is only one output for each input. Or for every value of x, there can only be one value for y. Okay? This setup over here on the left is not a function, right? Because the input 2 has more than one output, right? So it would not be a function, right? The one here on the right, right, that has them switched, that one does represent a function because each input has its own output. Right? So here's the thing, okay? That there's always got to be at least as many inputs as there are outputs. Okay? There can be more inputs and outputs, right? And there can be the same number of inputs and outputs, but there can never be more outputs than inputs, because if there are, then that means at least one of those inputs has to go to more than one of the outputs. Okay, so for every value of x, there can only be one value for y, and you can have all the x's, as long as they're different, it does not matter what the y's are. Okay? As long as the x's are different, doesn't matter what the y's are. All right, so let's look at a couple of scenarios to talk about this. From the items in a store to their prices on a certain date. Is that a function or not? All right, so let me ask you this. Okay, Sebastian, all right, if you go to the grocery store, okay, what's the one thing you would like to buy the most? Yes. Something you would want to buy. If you went to the grocery store with your mom tonight, what would you want her to buy you? Donuts, okay? All right, now, if you bought donuts, okay, and we'll say that you're only buying one donut in this case, all right? Are they going to give you options on prices for that one donut you buy? Or is it a set price? I'm going to buy this nice chocolate-covered donut with sprinkles on it. Are they going to charge you more than one price for that donut? Oh, no. Okay, so it only has one price. Okay. Hayla, how about you? What are you going to get? Protein bars? All right. Are they going to charge you more than one price on those protein bars? Or do they have a price on that protein bar? Here it is, and this is how much I'm going to pay. Okay, if it's just one, that's what you're going to pay, right? A certain price, okay? So if you go to the store and buy a specific thing, they're going to charge you one price for that. So would that be a function? And the answer is yes, because all the inputs are the items that you're going to buy, the outputs are the price you're going to pay. So this is a function. All right? They're never going to, if I go, my thing is going to be buying a bag of M&Ms, okay? All right? And each bag of M&Ms I choose to buy, which usually it's the medium-sized bag, they charge one price for that. They're not going to give me three options for prices for the M&Ms. Let's see, Mr. Coffee, do you want to pay $3.50, $3, or $2.50 for that bag of M&Ms? Well, no. I mean, I wish they'd give me options because I'm definitely going to choose the smallest one. So that's what they think. All right. Types of fruits to their colors. All right. Gracie, what's your favorite fruit? Apples. Okay. So when you go to the store and I look at the apples, are there more than one color apple? There are. Okay. Since there's more one color to one fruit apple, then this is not a function. All right, you got golden delicious and red delicious and pink. No, there's not pink delicious, but yep, you got all those different ones. All right, so you have to think about, all right, for every input, is there one output or could there be more than one outputs? If there's more than one output, then it's not a function. If there is only one output, then it is a function. All right, so think about this. All right, now there is a test for doing graphs to determine whether they're a function or not. And the test is called a vertical line test. If any vertical line passes through more than one point on the graph of a relation, then that relation is not a function. All right, so here's two examples. Here I have this graph here on the left. All right, they've drawn a couple different vertical lines. Always intersects one point because the graph is always moving from your left to right. Okay? Since the graph's always moving from left to right, it never goes back, then it's going to be a function. This graph on the right here, all right, it starts in the right, comes back to the left, and goes back to the right again. All right? So there are instances where a vertical line will cross more than one point, so it's not a function. So when in my head, even when we're looking at these things here, that's what I'm thinking about. Okay, all right, are there going to be 2 points that are going to be above each other on a graph? If there are, so with the same input, I got more than one output. If that happens, then it's not a function because the vertical line is going to go through those 2 points. And so I do that, think about that quite often. All right? So letter A here. If I draw a vertical line, and I take that vertical line and I go across here, does it ever cross more than one point? All right? All right? Never intersects more than one point, so that would be a function then. All right? If it never passes more than one point, it's a function. All right? Down here, all right, I have these two lines. All right? Well, that's going to always pass through more than one point, isn't it? Okay. So then this one would not be a function. Okay. It says if it's not a function, then they want us to identify 2 points that a vertical line would pass through. All right, so all you got to do is pick 2 points. Your x values must be the same on those 2 points. All right, so for instance, they chose 1, 1. All right, and 1, negative 2. All right, my vertical line touches both of those two. So to say that it's not a function, I need to list 2 points that prove that it's not a function. All right? And those 2 points would have to be the same x value with a different y values. So vertical line test, nicest thing there is. All right, draw a vertical line. Does it intersect more than one spot? If it does, it's not a function. If it doesn't, then it is a function. Okay. So tell whether these two are functions. If they are not, identify 2 points. All right, so let's look at 1, 7. All right, we're going to be using functions a little bit then. All right, here we have function notation. All right. Function notation is basically no different than anything you've seen before. You've done this before. All right. Here we've got f of x equals 5x plus 3, and we read that as f of x. That's not f times x. All right, it's f of x. And basically what happens is that the f of x just replaces y. All right, so we could think of that as y equals also. So if they say f of 1, that means that we've replaced x with the number 1. So since 1 goes in here for x, I'm putting 1 in there for x, and then I find that answer. It's just the difference is function notation. It does not mean multiplication. It just means the variable we're using is x or y or a or b. If it says f of a, then a is the variable we're working with. Okay? And all that means is this is a function. That means that, you know, for every value of x, there's only one value for y. Okay? Just the specific notation, and we're going to use that and do some evaluating. Right. And so here we have the function f of x equals 8 plus 4x. They want us to find f of 0, f of 1/2, f of negative 2. So all that means is we're going to put 0 in for x, 1/2 in for x, and negative 2 in for x. We put 0 in for x, simplify that, and we get 8. To find f of 1/2, we replace x with 1/2. So we have 8 plus 4 times 1/2. Half of 4 is 2, so 8 plus 2 is 10. But really all this is doing like the evaluating, we say when they tell us to evaluate when x equals 0, 1 half, and negative 2, so we put those numbers in. 4 times negative 2 is negative 8, so we get 0. So all that tells us is, basically they're saying this, okay, here's the x value, find the y value for me. All right? So these are actually representing points on the graph. So if we graphed 8 plus 4x, y equals 8 plus 4x, we'd have the point 0, 8, 1 half, 10, and negative 2, 0. Right, so here's a graph, and we want to find those same three. We want to find f of 0, f of 1 half, and f of negative 2. So 0, 1 half, and negative 2 are the x values for the graph. We want to find the y values then. Okay? That's all it's asking us. Here's the x, find the y. All right? So at 0, we go up to the line and we get positive 3. At 1 half, so we go over to 1 half, and where x equals 1 half, y equals 0. Negative 2, go over negative 2, up to the graph, and the answer is 4. So all that is, here's your x values, find the y value. Okay. How many of you remember doing that stuff before? You've done all that before, you remember it. Okay, good, great. All right. Okay. All right, graphing. In the notation f of x, f is the name of the function. The output f of x of a function is called the dependent variable. Okay? So f of x is the dependent variable. X, that variable that's inside the parentheses there, that's the independent variable. Okay? So here's an example. We have d of t equals 65t. The dependent variable is d of t. What do you think d of t stands for? What do you think? D of t. Probably distance and time. Okay? The distance you travel depends on how much time you travel for, right? And so if they say d of t equals 65t, well, then what does that 65 probably stand for? Okay. Used to be the speed limit was 65 a lot of places. All right, so the 65 is probably how fast you're traveling, and t is the time. So how much distance would you travel when going 65 miles an hour? All right, for a certain amount of time. Okay. So lots of times if they give you a word problem and they want you to write a function for it, then you need to use appropriate lettering. Sometimes it's the cost of X items. Something like that. So my 5 bags of M&Ms, all right? All right, graphing. How many of you are very good at graphing? Everybody, right? Okay. Now, these are easy. We all know how to do them. I'll go through them real quick. 0, 4. X is 0, Y is 4. 1, 5. 2, 6. 3, 7, and 4, 8. All right, graphing them. I'm sure we all remember how to graph points. Right, Garrett? Okay. The line. f of x equals 3x minus 1. Miss Brown, what do I graph first of 3x minus 1? The 1, okay, the minus 1, right? Okay, and what do we call that thing? Michael, help her out. The y-intercept. Okay, that's the y-intercept. So I mark the y-intercept. Okay, there's my y-intercept at negative 1. All right? Then what, Terry? Taylor? All right, so this is a good question then. All right, who knows? What do I do next? All right, Kayla, what? All right, the 3x is the slope. And so that is 3 over 1. So from the y-intercept, negative 1, I go up 3, 1, 2, 3, and over 1. Put a point there, and then draw my line. Okay? And then arrows. Right. So we graph the y-intercept, and then we do the slope. So if the slope's a whole number, it's that number over 1. So if it's a positive slope, we go up that number and we go over to the right. So it's always up or down and always to the right. So if it's a negative 3 over 1, then I would go down 3, but then I'd still go 1 to the right. All right? So remember, if the slope is positive, the graph goes up as it goes to the right. If the slope is negative, it goes down as it goes to the right. Okay? But we always graph the y-intercept, then the slope, draw our line to those 2 points. All right. Okay, so graph these two. All right. Okay, last one, little word problem for you. The algebraic expression used to define a function is called the function rule. The function described by f of x equals 5x plus 3 is defined by the rule 5x plus 3. To write a function rule, first identify the independent and dependent variables. Carnival charges a $5 entrance fee and $2 per ride. Write a function to represent the total cost after taking a certain number of rides. Right? So we need our independent variable. Right? And so what variable should we use for our independent variable? What is the thing that changes, Mr. Vickery? No. Good try. Right? What thing changes? Okay. The number of rides, right, is what changes. Okay, so that's our independent variable. So we're going to use R for our independent variable, and that means the number of rides. Okay, R will be our independent variable, and it stands for the number of rides. Now, our dependent variable is going to be what, Mr. Vickery? What's the dependent variable then? The cost of the rides. Okay, so we'll use C of R. Cost for our rides. Okay. Now the letters you use do not matter. Okay, but all right, you should use letters that make sense for the problem. Okay. like R for rides, C for cost. Okay? So the cost for our rides is, let's see, $5 entrance fee. Boy, that's pretty good. If we went to Cedar Point, this would be a whole lot better deal than what they charge you, wouldn't it? $5 to get in and $2 per ride, because since you're standing in line for 2 hours at the Top Thrill Dragster, you know, there's 2 hours of my day. It only cost me $2 to stand there, you know, so that'd be a whole lot better deal. All right. So Stephen, what's the rule? All right, 5 plus 2R. Cost me $5 to get in. Every time I get out of a ride, it costs me $2. All right, that's more like going to the fair, right? Okay, Jackson County Fair. I don't know, I've never been to Chelsea Fair. Is Chelsea Fair about the same cost as Jackson? Okay. All right. So the cost per ride, $5, 5 plus 2R. So it says, what is the value of the function for an input of 12? All right, input is what? What does input refer to? Okay, R, the number of rides, and what does it represent? So we're not only going to find the number, we have to write a sentence that tells what it means. C of 12 equals 5 plus 2 times 12. So 5 plus 24 is 29. All right, so who can give me a sentence that, so tell me what to write down there. If I put input of 12, I get an output of 29, what does it mean? All right, Mr. Vickery, what does it mean?
It means that how many rides you have something for how much money it costs.
Right, can you put it in a sentence for me that involves the 12 and the 29?
12 rides equals $29.
Okay, that's pretty close. That's not bad, all right? So if you take 12 rides or go on 12 rides or do 12 rides, it will cost you $29. Right? If I go on 12 rides, it will cost me $29. Right? It needs to be a complete sentence there to the best of your ability. Okay? All right.